Hi everyone, I'm Yiying Chen from Chemistry first year, introducing about limiting region and yield. First, let's review some concepts from Module 1. We were required to understand limiting region and also find it during a chemical reaction. So here's the definition of limiting region. It means the first reactant that runs out during the reaction. Conversely, there will also be an excess reactant, and some of it will be left over when the reaction is finished. Then let's look at the equation of percent yield. It equals to the ratio of actual yield and theoretical yield. This should be a number that always less than 100%, and I will introduce why in the following lecture. To figure out why theoretical yield is larger than actual yield, we need to firstly define theoretical yield. It means the maximum possible mass of a product produced in a chemical reaction, and this product will correspond to the limiting region we found before. Since the theoretical yield refers to the maximum possible mass, there will be no mass larger than this number to be produced during the reaction if nothing goes wrong. Other than definition, there is also some possible situation that may occur during the experiment can give an explanation to why theoretical yield is larger than actual yield. This possible situation may decrease the actual yield. Firstly, there may be some small amount of solution left on the side of the container. Also, the reaction may not be completed. During some experiment, there may also be chemical left on the filter paper. There is also many other situations that will slightly decrease the actual yield, so the actual yield is usually smaller than theoretical yield. Then let's look at some real-life example of the concept theoretical yield. To begin with, I will start from a really easy example of hot dog and its bun. It's an example that I saw from Chem Academy. So let's assume we have 5 hot dogs and 4 buns. If we want to make the product hot dog in bun, under the situation that we only have 4 buns, there is only 4 hot dogs needed to complete the reaction. Therefore, there will be 1 hot dog left over as the excess reagent. Since the number of reactants, hot dog, and bun may not perfectly match their moles ratio, and bun is less than hot dogs in the ratio, so there will be excess reagent of hot dog, and the bun will be limiting reagent in this situation. Now let's look at a real-life example including chemical reaction. A common way for people to get pure metal is to extract from ores. Titanium, as the metal of choice in airplane, is strongly demanded by humans. To get pure titanium from ores, it's necessary to go through the extraction of titanium, which including 2 chemical processes. Today we will mainly focus on the second stage. After we get titanium tetrachloride, we need sodium as a more reactive metal than titanium to react with titanium tetrachloride and extract titanium. That leads us to today's practice example. For instance, we have 140 grams of sodium and 200 grams of titanium tetrachloride. Determine which is the limiting region and why. Determine the theoretical yield of titanium. Please pause this video for 1 minute to think about it, and then I will show how I do this question. So to solve this question, we can start from getting the molar mass of sodium and titanium tetrachloride. We can just use the molar mass of sodium from the periodic table. And for titanium tetrachloride, we need to add the molar mass of titanium and 4 times the molar mass of chlorine from the periodic table. Then, since we are provided with the mass of both sodium and titanium tetrachloride in our question, we can calculate how many moles for sodium and titanium tetrachloride by multiplying the mass from the question with the reciprocal of the molar mass that we calculated previously. So there is 6.09 moles of sodium. And for titanium tetrachloride, we will do the same by multiplying 200 grams with 1 mole over 189.67 grams. And we will get 1.054 moles of titanium tetrachloride. Since the ratio of titanium tetrachloride and sodium in the balance equation is 1:4, so by dividing the number of moles of sodium with 4, we can get 1.52 moles, which is theoretically the number of moles for titanium tetrachloride if the sodium is the limiting reagent. However, 1.52 moles is larger than 1.1 moles that we calculate for titanium tetrachloride. So the titanium tetrachloride is the limiting reagent for this question. So based on the result of limiting reagent, we can calculate for the theoretical yield of the products in this reaction. So for titanium, since the ratio of titanium tetrachloride and titanium is 1:1, so the number of moles of titanium is equal to the number of moles of titanium tetrachloride. Therefore, we can calculate the mass of titanium by multiplying the number of moles with the molar mass of titanium that can be found from the periodic table. So here, we calculate there are 50.3 grams of titanium as the theoretical yield of titanium in this equation. We also need to convert the final answer to 2 because 140 grams is 2 in question. The reason why we set sodium as the excess reagent in this question is to reach our goal of extract titanium. So to make titanium as the limiting reagent, we can make sure the reaction of titanium tetrachloride is completed and we can get titanium as much as we can. Since we mentioned about the question that why theoretical yield is larger than actual yield previously, here are some tips to show how we can improve yields in the experiment to increase the number of actual yield. So here are some tips. Before the experiment during the setup, we can examine all the equipment before starting a lab. For example, the flask and beaker. Then we can weigh the reactant as precisely as we can, like using a balancing with digital showings. Then during the reaction, We can add solution drop by drop if necessary to control our amount. Also, we need to pay attention to conditions like temperature and pressure during the experiment, since they may affect our results. To conclude our project today, I will summarize what I talked about during this lecture. Firstly, we reviewed the definition of limiting reagent and the equation of theoretical yield. Then I introduced some reasons for actual yield being smaller than theoretical yield. Coming up with some real-life example of theoretical yield, we can see the importance of using excess reagent in some reactions in daily life. Then, to improve yield in a laboratory experiment, we can use some tips like examining the flask and beaker before the experiment to make sure they are dry and clean, so we can increase our actual yield and get our percent yield as close as to 100%, because the higher number we get, it means more precise our experiment is.